we will be looking at a wrapping function. First, if you'd like to pause this to write this down, feel free. A wrapping function takes a length of a real number line, either positive or negative, originating from a designated point of the object to be wrapped, and wraps the designated portion of the number line about the object, either in a counterclockwise direction, which we'd be considering positive, or in a negative direction, which would be clockwise. So at the endpoint of the wrapped segment corresponds to an ordered pair on the object. Now it's kind of wordy, but actually it's really quite simple when we show you the visuals. The notation we're going to use is W of n, which means a wrap of length n, and that's going to equal some ordered pair x, y. So again, n is the length of the number line to be wrapped, x is the x-coordinate of the endpoint on the object, and y is the y-coordinate of the endpoint. So thinking back a little bit to what we did on the mod functions, a mod function is a periodic function. And it's important to remember that the period of a function is defined as the smallest interval over which the values of a function recur. All periodic functions have the property that f of x plus the period will equal f of x. In other words, if you add the period, you're starting at the same value. You get back to the same value. That's what we mean by the values recur. Mod functions are an example of a periodic function, which you saw before. Let's do a square wrap example. So let's start out by defining the starting point of any wrap as the right-handmost point. In this case, it would be the point 3, 0. It's where the right-handmost portion of the figure to be wrapped meets the x-axis. That's how we will start every wrap that we do. So let's start with a wrap of 0. Well, a wrap of 0 means I start at the starting point and I don't go anywhere, meaning I should be at the point 3, 0. Next is a wrap of 1. So I'm out at my starting point, which is on the right-hand portion of the figure to be wrapped, and I move one length along the object in the positive direction. See, going in the counterclockwise direction, which would be this way, is positive movement. So I'm actually taking a number line and kind of wrapping it around this figure, but only for a length of 1. Another way to think about this is you have a little bug, and the bug is standing on the object, and it's going to move 1 unit around the perimeter, bringing me to the point 3, 1. So a wrap of 1 brings me to 3, 1. Now I'm starting here on the right side of the object. I'm going to wrap a length of 3 because the next problem was wrap 3. Moving up, 1, 2, 3. Brings me to that corner, the point 3, 3. Next, we're going to go to wrap of 6. Now again, we're just moving around the perimeter of the object. You could think about nails being in each corner of this figure and wrapping a string around it as tight as you could. So if we had one end of the string tied over here on the right side at the starting point, and you pull the string of length 6 around this way, and it would just go right up along the top, 1, 2, 3, and over to the left, 1, 2, 3, total of 6. A wrap of 6 brings you to the point 0, 3. Next, a wrap of 12. Now here's where we can start using some symmetry. We knew a wrap of 6 was 1, 2, 3, 4, 5, 6 there. Well, since the figure is symmetric, it's going to be another 6 over to here. So a wrap of 12 simply takes us to the point -3, 0. Again, using our symmetry and knowledge of a square, this figure over here on the right, this little piece, is going to be the same size as the piece down here. So if this was 6, this other piece is 6, so that's 12, and another 6 is going to bring us to 18, which is right down here at the bottom of the square. So 0, -3. For a wrap of 24, 6, 12, 18, 24, we're back to our starting point, which means the point 3, 0. Now, a wrap of 3.7, we'll start here at the starting point. We'll go up 3 and then over this way, 0.7. That would be a total of 3.7 units moved around the circle, which would bring us to an x value of 2.3 and a y value of 3. We are now up to our first negative wrap, a wrap of -5. Well, so far, every wrap that we've done, we've moved up and around in the counterclockwise direction. So to do a negative wrap, you actually have to go in the clockwise direction, which would be like that. So we will start again at our starting point on the right-hand side and move clockwise 5 units. 1, 2, 3, 4, 5. Bringing me to the point 1, -3. The next question asks, what is the period? Well, when would the values start repeating themselves? Well, I'm sitting here thinking to myself, I'm at the point 30. I go all the way around the object, and again, I'm at the point 30. I go around the object again, and I'm back to the point 30. So I went 24 units around the figure to get back to repeating values. So the period is actually the same as the perimeter, which in this problem is 24. Why is that helpful? Well, the next problem asks for a wrap of 1,240. Well, that's quite a big wrap. But we can make it a lot easier if we think about doing this as a mod function. So 1,240 mod 24, the dividing out by 24 will take care of all the whole number times around this object. So when you divide 1240 by 24, you get 51.6 repeating. Okay, so 51.6 repeating means that you would have to go around this object 51 times, but then there's 0.6 repeating left over. That means 0.6 repeating out of 24, because 24 in this case is the whole unit. So to find the mod number, you simply take 0.6 repeating and you multiply it by the 24, and you now have 16. So to find a wrap of 1240, you really just need to find a wrap of 16. So let's check it out. We knew this was a wrap of 12 over to here, 13, 14, 15, 16, -2, -3. We can do the same approach for 3,412. A wrap of 3,412 would be done by 3412 mod 24, which when we do the division on a calculator, we get 142.16, the 6 repeats. Again, the 142 represents the number of times you would go completely around the square, and the 0.16 represents the fractional part remaining to go around. Remember, when we divide by 24, that's the whole. So the whole 24 means the whole perimeter. So we have to go 0.16, 6 repeats there of the perimeter, simply multiply it, and that means we go 4 units. So this is going to be the same as a wrap of 4, which is 1, 2, 3, 4 units, the 0.2, 3. Now we're up to another negative wrap. However, this negative wrap has a value larger than 24. So in other words, we're going to go around the square more than once. As a matter of fact, we can think about this as 97 mod 24. If I do the division, I'm going to get 4, remainder 1. Or you could do the decimal and use the calculator as I showed you before. But 24 times 4 is 96, so 97 minus 96 is remainder 1. So this would be the same as a wrap of 1. However, the 97 was negative. So this is going to be the same as a wrap of -1. So in other words, we went around 4 times in the clockwise direction to get us back to the starting point, and then 1 more right down there, bringing us to the point 3, -1. The next question asks for the domain. The domain of a wrapping function is always going to be the same answer. If you think back to the notation from the last page we were on, the input values were always n. We do wrap of n. So in this case, the domain is always going to be n, such that n is an element of the real numbers, because we can wrap any positive or any negative length around the figure. The range is quite a bit trickier to think about, though, because typically we used to think about range as having to be just y values. Domain was x's and range was y's. Well, in this case, we're going to use n's for the input values, and an ordered pair x comma y for the output values. So any ordered pair that lies on this square would be the range. So that's kind of tricky to write. So we'll just write it as the set of x comma y's, meaning the ordered pairs, x comma and y coordinates, on the square. And we might want to just note that -3 would have to be less than or equal to x, which is less than 3. So in other words, the largest and smallest values of x's are given. And the same thing with the y values. Now keep in mind that we do say that the ordered pairs have to be on the square, because if you just paired up any x and y that are between -3 and +3, I have to fix this +3 over here. Like, for example, if you picked x equals 1 and y equals 1, the point 1, 1 is not on the square. That's right here. So you couldn't just use any x value and any y value that are between -3 and 3. They actually have to be points that are on the square. That's why we notated it like that. Well, I hope you enjoyed the first wrapping functions video, wrapping functions video 1. And that is all for right now. Let's turn this off.